Now the next method is partition method. Partition method to solve the system of equations and see the procedure. This method is used. This method is used to find the inverse of the matrix. To find the inverse of the matrix. Okay, and after finding inverse of the matrix, you can get the solution, that is x equal to A inverse into B. Okay, let the coefficient matrix capital A be partitioned or partitioned as, now this is important, capital A equal to the, see how to partition, B C D E, right, like this, B C D E. This is the partition. Matrix A is partitioned into 4 sub matrices. One is B C D E, moving right side. Remember this, B C D E. Okay, next one, where B, capital B is an R by R matrix. Capital C is an R by S matrix. Capital E is an S by R matrix. And capital D is S by S matrix. What is R, S, that we can determine in the problem directly. Okay, here, and R and S must be, R and S are positive integers. Okay, next step. Now let inverse of the matrix, that is A inverse, is partitioned similarly as A inverse equal to, now again partition of A inverse. Now A is over, partition of A inverse, x y, now there is a change here, z, x y z v, like this, x y z v, where x y z v are matrices of the same order as B, C, E, D respectively. That means what? Just I am giving hint here. Okay, just to remember, this is how we decide partition of A, B, C, D, E, like this. Okay, now B is X, orders like this, B order, X order is B, Y order is C, next one, Z order is what? In place of Z, what is the value matrix? E, and in place of V, that is D respectively. Okay, now then we have what is A into A inverse, that is I. Now let us write these two, A into A inverse. What is A? B, C, D, E. Okay, B, C, D, E multiplied by X, Y, Z, V. Actually dotted lines, you have to put dotted lines, equal to what? Identity matrix. That identity matrix I am writing I1, 0, 0, I2. Because all these matrices are sub matrices, These identity matrix is also taken in the form of submatrices. Now taking product on both sides and comparing, taking product on the left side and comparing, let me write, taking product on the left side and comparing on both sides, and comparing on both sides, what we get, now this is very very important, this we get b into x plus c into z equal to I1. You can compare this after taking product. And the next one is what, by plus cv equal to 0. 1 position, next 2 position, next 1 position, e into x plus d into z equal to 0, next 2 position, ey plus dv equal to I2. Now solving these equations, we get, you have to remember, to solve the problem you have to remember now this set of solutions. Capital V equal to d minus e b inverse c whole inverse, this is V matrix. Y matrix is minus b inverse c V, and Z matrix is minus d minus e b inverse c whole inverse multiplied by e b inverse. So that is taking e b inverse inside this matrix, inside this bracket, you will get minus v e b inverse, minus v e b inverse. And lastly x equal to, you will get b inverse I1 minus cz, and this simplified into b inverse minus b inverse c z. Okay, now this set you have to remember, this is very very important. Remember this, remember these formulae to solve problems, okay. And what is the required here? See in this one, what are the required? I have to, after getting a b c d e x y z, b inverse is required, right? And one more is required, what, this entire, this one and this same. So what are the requirements here? We need to find two inverse matrices, b inverse, and one more is what, d minus e b inverse c whole inverse. Okay, these two of what order? Of orders r and s respectively. That means r by r and s by s, r and s respectively, r by r and s by s. Okay, this method is useful. What is the main idea of this method? This method is useful when a few more unknowns and consequently a few more equations, right? If I add unknowns, then equations also increases. Few more unknowns are added to the original system, and the solution of the new system is required, and the solution of the new system is required. required. See what is the idea? When we this method is useful, for example, three equations are there, three equations something, three equations are there. If I want to add one more variable, x1 x2 x3, here also x1 x2 x3, if I want to add x4 one more variable and one more equation also, then already 3 by 3 system solution is known, okay, by solving any one of the method. But in this system, if I add one more variable or one more equation, then to solve that system, this partition method is useful. Okay, and one more is okay, this is the method, explanation of the method. Let us do some problems based on this. Now one problem: determine the inverse of the matrix, the inverse of the matrix 1 1 1 4 3 minus 1 3 5 3 using partition method. Using partition method, hence find the solution of the system of equations x1 plus x2 plus x3 equal to 1, 4x1 plus 3x2 minus x3 equal to 6, 3x1 plus 5x2 plus 3x3 equal to 4. Okay, this is the problem. Now solution. First let us find inverse of the matrix by using partition method. Okay, what is A is given as 1 1 1 4 3 minus 1 3 5 3. Okay, let matrix A be partitioned as okay, I'm writing here A equal to, let me take this 2 by 2 matrix. Okay, one submatrix, and this 1 minus 1 another submatrix, and next one 3 5 is another submatrix, and 3 is 1 by 1 matrix. Okay, and what is A inverse, and what is our A inverse formula? The matrix partitioned as x y z here, z and v. Now this is the partition, right? Now therefore what is the matrix? Now this is B. What is matrix B is 1 1 4 3, 2 by 2 matrix. And what is C is 1 minus 1, this is 2 by 1 matrix, right? B C D, what is D? Just 3, that is 1 by 1 matrix, right? Next E matrix is what? It is a row matrix, 3 by 5 means 1 by 2 matrix, 1 by 2 matrix. These are the matrices. Now to find inverse of the matrix, we need B inverse. Okay, therefore now B inverse equal to what? Adjoint B by determinant B. And for 2 by 2 matrix, you know what is B matrix here? B matrix is what? 1 1 4 3. So what is determinant here? 1 by 3 minus 4. And adjoint means what? Interchange these positions and change the sign of these positions, right? Intermediate technique. So what is B inverse is now? This is B inverse is minus 3 1 4 minus 1 multiplying by this minus 1. Okay, determinant value. Next what I required, one more inverse is required. What is that? D minus E B inverse C, right? First what is D? 3, and this is minus, what is E? 3 5. Next what is B inverse? Minus 3 1 4 minus 1. And what is C? It is 1 minus 1, right? So what is this becomes? Finally this is 3 minus 3 5, isn't it? This is what? 2 by 2 matrix, and this is 2 by 1 matrix. So result is 2 by 1 matrix. Minus 3 into 1 minus 3 minus 1, So this is minus 4. This is 4 plus 1, 5. Now this is 3 minus, this is 3 into this is minus 12, minus 12 plus 25. This is 13, right? 3 minus 13. So minus 10 is the value. Minus 10 is the value. Next one. What is the next one? What is v value? Therefore inverse, what is this? So this, for this one inverse is what? V. D minus, I have to find two inverse matrices. One is b inverse and for this whole inverse, and that whole inverse is represented by what? V. So minus 10 whole inverse, that implies v equal to 1 by 10. V equal to minus 1 by 10. V is over and b inverse is over, right? Next value is what? Y. Now what is the y formula? Y equal to b inverse c v. Okay, so what is b inverse? Minus 3, 1, 4, negative 1. What is c value? C is 1 minus 1. And what is v value? This is not matrix, this is constant. After taking this product, see, this is 2 by 2 matrix and this is 2 by 1 matrix, already we did here. So minus 4, 5 multiplied by minus 1 by 10, multiplied by minus 1 by 10, isn't it, right? This y is over. Next one matrix is z. What is z? Minus v e b inverse. Minus v e b inverse. Minus v means what? 1 by 10, minus multiplied by minus. Next one, what is e? Matrix e is 3, 5. This is 3, 5. And b inverse is what? Minus 3, 1, minus 3, 1, 4, minus 1, right? So after taking this, this is what matrix? This is 1 by 2 and this is 2 by 2. So this is 1 by 10. Result matrix is what? 1 by 2 matrix. So 3 into 3, minus 9. Minus 9 plus 20, minus 11. Next 3 minus 5, minus 2. Done. So this value is what? Z value is minus 1 by 10. Once again, this is minus 9 plus 20 plus 11, right? Right. So the answer is 1 by 10. 11 minus 2 is z value. Is z value. Next, after z, last value x. What is x equal to? B inverse minus b inverse c z. What is b inverse? This b inverse is minus 3, 1, 4, minus 1, minus 3, 1, 4, minus 1, and the c value. C value is, what is, where is it? C value is 1 minus 1, right? And z, what is z value? Minus 1 by 10, this is the constant, multiplied by or plus 1 by 10, minus 11, sorry, plus 11 minus 2, plus 11 minus 2. Let me write once again. What is this? 1 by 10, 11 minus 2. Okay, matrix. So after taking this entire product, this is minus 3, 1, 4, minus 1, right? Minus 1 by 10, 1 by 10. Let me take the product of these two, 2 by 2 and this is 2 by 1. Result is 2 by 1. Minus 3 minus 1, minus 4, 4 plus 1, 5, multiplied by 11 minus 2. So this is equal to 3 minus 3, 1, 4, minus 1, minus 1 by 10. This is what? 2 by 1. And this is what? 1 by 2. So result is 2 by 2. 2 by 2 means first thing minus 1 position, minus 44. This is 8 and this is 55 and this is minus 10. Okay, and finally x equal to, after simplifying, this is 1.4, 0.2, minus 1.50 minus 1.50. This is x value, right? Therefore finally, therefore what is A inverse? A inverse is what? X y z v, right? Let us substitute one by one. First, what is x value? 1.4, 0.2 minus 1.50. X value is over. Okay, just I'm showing the partition. And what is y value? Y value, y is what? After dividing by 10, 0.4 you will get, minus 0.4 you will get, and this is 0.5 you will get. Next one, what is z value? It is 1.1 and minus 0.2. And lastly, in this value, v value minus 0.1. Okay, this is A inverse. Okay, and without dotted line, 1.4, 0.2 minus 0.4 minus 1.5, 0, 0.5, 1.1, 0.2, negative, minus 0.1. This is A inverse. After getting A inverse, what is the solution? Therefore solution of the given system, solution of the system Ax equal to b is x equal to A inverse b, x equal to A inverse b. So x equal to, what is A inverse? 1.4, 0.2 minus 0.4 minus 1.5, 0, 0.5, 1.1 minus 0.2 minus 0.1 into b. What is our right side matrix in the given system? 164. So this value is x equal to, you will get 1.5 minus 0.5. Now we did this problem in other methods also. This is 1 by 2 minus 1 by 2 is the solution, is the solution. That means x1 value 1, x2 value 1 by 2, x3 value minus 1 by 2. Okay, this is one problem. And another one, find the inverse, find the inverse of, what is the matrix? 2, 1, 1 minus 2, 4, 0, 2, 1, 3, 2, 2, 0, 1, 3, 2 minus 1 using partition method, using partition method. Solve this one assignment problem. This is assignment. Okay, this is partition method. So how many direct methods are here? Finally, direct methods are, first one is what? This first one, this one, partition method, Cholesky method, right? Next one, Gauss LU decomposition method, and the next one, that is triangularization method, Gauss Jordan method, and Gauss elimination method. These are the methods. One is Gauss elimination, next one Gauss Jordan method, next one triangularization method, LU decomposition, triangularization method. Next one is what? Cholesky method. Next one is what? After Cholesky, this partition method. Partition method. These are the methods. These are all what methods? Direct methods. Means gives exact solution. Gives exact solution. Next class we will take iterative methods. Means if the system does not possess exact solution, then we required approximate solution. Then how to find approximate solution for the system of equations? Those are called iterative methods. Okay.